Welcome to homework.
Welcome to the problem number 32.38, chapter 32, electromagnetic waves. So we have a small helium-neon laser and which has red visible light with power of 5.80 milliwatt, and the beam diameter is, so let's say this is the beam or the laser. The diameter of this one is equal to 2.5 millimeter. So this is the diameter. So we need to first find out the amplitudes of electric and magnetic fields, and then we will find out the average energy associated with electric field and magnetic field. Then we will find out the total energy contained in 1 meter length of the beam. So let's say this is 1 meter or the length. So we need to find out the how much energy is contained within this. So this is the average energy. So we can find out. So we will go one by one. And the first step is to find out the amplitudes of electric and magnetic fields. So we have part A. So we have intensity here, which is power over area. So this gives us power is 5.8 milliwatt, 10 to the minus 3 watt over area. I'm talking about the area. So this is the area. So we have pi d over 4 square. So we have pi over 4 times 2.5 into 10 to the minus 3 meter square. So this is equals to 2.5 into 10 to the minus 3 meter. We have to convert the units into the SI units. And this gives us equals to 1182 watt per meter square. So this is the intensity. Now we can calculate the Emax using this equation. So we have Emax equals to root under 2I over mu naught C. We know everything, so these are constant, and this I we know. So putting all this, we have Emax equals to 943.5 volt per meter. So let me write you the value of the E naught. So E naught is equals to 8.85 into 10 to the minus 12 Newton, Coulomb Newton square. Coulomb Newton square. And C naught is equals to 3 into 10 to the power 8, which is the speed of light meter per second. So use this constant here. So that's why we have 940.5 volt per meter. Now we'll find out the B max. So we have B max. B max is equals to E max over C. So putting all this, we have 943.5 volt per meter over 3 into 10 to the power 8 meter per second. So this gives us equals to 3.148 into 10 to the minus 6 Tesla. So that's your answer for B max. So this is the magnetic field amplitude and this is the electric field amplitude. So we are done with the part A. Now we go to the part B. So we need to find out the average energy density. So we have UE average, the average energy density contained in the electric field. So which is equals to 1 by 4 E naught E max square. We know E naught, we know E max. So just putting all these values, we have 1 over 4, 8.85 into 10 to the minus 12 times Emax square. So Emax is 943.5 square. So putting all this, we have equals to 1.97 into 10 to the minus 6 joule per meter square cube. So this is the density or the energy density. So because we have meter cube here, that means that this is a density term. Now we have UB average. So we know that it's just a sinusoidal electromagnetic wave. So definitely B average should be equal to this one. So we have 1.97 into 10 raised to minus 6 joule per meter cube. But you can also find using this value, so which is equals to 1 over 4 mu naught B max square, and which is equals to B max is our, we have this value 3.148 into 10 raised to minus 6 square over 4 into 4 pi into 10 raised to minus 7. So this gives us 1.97 into 10 raised to minus 6 joule per meter cube. So this is your answer for electric and magnetic field energy density. So we know that mu naught is equals to 4 pi into 10 to the minus 7 Tesla meter per hour ampere. So using this we have this answer. So both are same, so both are equal. Now going to the C part. So we have need to find out the energy contained within this length. So the whole volume of this is equal to, is a cylinder. So this is a kind of cylinder having length L and diameter D. So we know that air, the volume of the cylinder is equals to pi r square h, which is equals to pi d square over 4h. H is a 1 meter, so that means pi d square 4 meter cube, which is the same value as this one. So we use this value here, so which is this value. Now finding out the total energy. So total energy is U average. So we have U average plus UB average times, this is the total average, so which is equals to 3.94 into 10 to the minus 6 joule per meter cube. So this is the total energy density. So we need to find out the total energy. So total energy is, let's say this is U, the capital U, which is equals to U average times volume. So we have this volume here. So putting all this, we have 3.94 into 10 to the minus 6 joule per meter cube. We have H equals to 1 meter times pi d or pi r square, which is equals to 1.25 into 10 to the minus 3 square. So this comes out to be 1.93 into 10 to the minus 11 joule. So that's your answer for this question. Thank you for watching the video.